follow at home, or like, review them later, or whatever. They're going to be there, so you don't need to like take that many notes. A little bit about me. I'm a principal software engineer at CV Library. I work here in London, and I have a little bit of experience in this area because a couple of years ago I wrote a Perl agent for New Relic using Newfangle. I gave a talk about that at the Ephemeral Miniconf a couple of years ago. And a lot of the work that I'm going to be talking about today extends from that work. We're also proud to be sponsoring LPW again. We have a stand, so come talk to us. We're a friendly batch. I'm not sure how much people here are familiar with OpenTelemetry. So I'm just going to give you a little bit of a tour. OpenTelemetry is a vendor-agnostic observability framework, which graduated as a cloud-native foundation project. And it's an interesting project to look at because it's vendor agnostic, but also because it has a lot of weight behind it. It has a wide adoption, and it has a low probability of failure, I think. Observability in general is the ability to determine the state of a system by its outputs, and in the context of software engineering in particular, those outputs are telemetry data. And the telemetry data can be broadly separated into three categories, which are traces, where you have these events that have a start and an end, and they're related to each other, and they define transactions that can span across applications, so they can be distributed. Then you have metrics, which are things like the ones that you would record using, say, stats_d or something like that, where you have scalar measurements that are time-stamped. And then you have logs, which are the same old logs that we're familiar with, but in the context of telemetry, they're not just living in some file in your local system, but exported to some processor elsewhere. And it is a framework because it only cares about the generation and the collecting of this telemetry data. It doesn't care about anything else. OpenTelemetry makes no assumptions about how the data is going to be processed, visualized, stored, analyzed. All of that is left to additional tools provided by third parties or extensions. It does this. It supports this sort of multiple backends, etc., by having this modular approach, just a little bit like the one that you would have for, say, log any or metrics any, where you have an API layer that allows you to interact with the system without doing anything, basically. And then you have a pluggable SDK that you can enable that turns that API into something that is actually doing proper work. And in the case of OpenTelemetry, there's also an ecosystem of integrations that allow you to either add additional export formats or additional processors or additional code instrumentation. I'm going to talk a little bit about more of that later. There's currently examples of all of these types of libraries on CPAN, and I'm going to be showing some of those. With that out of the way, I want to show a little bit about how the API looks, how that initial API layer looks. And specifically, I'm going to be talking about the one that deals with traces, since that's the one that is better supported by this library, and also the one that most people think of when they think of telemetry. In the context of OpenTelemetry, the unit of the trace is the span. So a span is the unit that has information about the start and an end of a task. And that's the one that defines these traces. In things like, say, New Relic, you would have a transaction that has segments, for example. But in New Relic, there is no distinction. The transaction is defined itself by a span that has no parent, basically. And you'll see in some of the examples later that there is this dance that you go through. You have a tracer provider that provides a tracer that then you can use to create spans. And that's a paradigm that is pretty common in OpenTelemetry. It's there basically to allow these extension points that are needed for the modularity. So in the code, it would look basically just like that. You get a tracer provider, which then you use to get a tracer. Some of these methods accept parameters, but in this case, the defaults are fine. And then you can use the tracer to create a span to record some data. And what kind of data? It's not just the start and the end, but the spans can hold additional types of data. So they can hold attributes that you can use to define what the span is. But they can also have links to other spans that don't necessarily need to be from that trace, and they can have events, and the links and the events themselves can have attributes. So it's quite a complex data structure that's also quite versatile. And OpenTelemetry defines some of those attributes as standard and defines what they mean and what values they can have, etc. Spans, like I said, they can have parents. And if there is no parent, that span is the root span. But of course, that raises a question, which is, if you're somewhere deep in the code and you're generating a span, how do you know if there is a parent? How do you know if that is the root span, or if there's another parent that you have to link to? And the way that OpenTelemetry propagates this data is through the context. Now there are some languages like Go, for example, that have context objects. It's a little bit like that. But for languages that don't have like a native context object, like say Python or Perl or Ruby, the OpenTelemetry defines its own context. And there's some assumptions that we can make about this context object. First of all, there is always a current context. Even if you've never set one, there's like a current context that is like the background context. And you can get that context, or you can replace it. You can say from now on, this is the current context. And you can use that to store arbitrary data. But as you can imagine, passing a context object to, say, like other code that will do whatever it does with it makes for a pretty awkward object to use. So in order to make it usable, there's two features that this context object has. One is that whoever writes the data has control over who has access to that data. And we can talk about how that is implemented, but the implementation doesn't matter that much. And the other thing is that a little bit like Ingi's immutable distribution on CPAN, these objects are immutable. You can write to them, but when you write to them, you get a new instance. The original instance is left alone. So how would that look to be used? If you take, for example, the span that you created with the tracer from before, you can say, well, now store it in a span. And you do that through this OpenTelemetry trace package, which owns the writing of a span. And then you get a new context that you can say, well, now this is the current context. And then later, any other scope can say, well, give me the current context, and then give me the span that is in that context. And if there is, in the case where there is no, if you've never set a span, the span that you get is like marked as invalid. And that's the one that indicates, well, there is a span, you can run operations on this, but it's not going to do anything useful. So how would you use this on like a library that you want to release on CPAN? There's two main ways to do this. The first one is to just use the API directly, but you can also release these integration libraries that I was talking about before. If you're using it directly, there's some benefits. You can have full access to all of the internal things in your library, and you're generating your own data, which might be good or bad. But the big thing is that you're now depending on OpenTelemetry directly, which means that all of your users are going to basically pay the price of OpenTelemetry, even if they're not interested in it. So there's this, and let's look at how that looks. So let's say you have some fancy package that is doing some very important work. You would have to first load the API, this like API layer. Then you would have to do the thing that we mentioned. You create a span, and you can add whatever attributes you want. Then, in this case, using defer, you need to make sure that the span will end at the end of this operation. Make sure that it propagates correctly down the stack. And then these are optional, but depending on your application, it might actually, well, certainly be desirable, but in some cases, the specification requires it, that you mark the span as either successfully finished or unsuccessfully finished. And as you can see, that is quite a mouthful, a lot of finicky details. So there are some experimental convenience methods. So all of that can be replaced with this method, which has the cost that everything needs to be indented one level. I've been in some conversations about like how we can make this even simpler, but for that I would need the help of smarter people than me. there are some in this room, so that would be useful. The alternative is to use an integration library, which would live in this OpenTelemetry integration namespace. And again, there's examples of this on CPAN. The benefit is that you're not depending on OpenTelemetry directly, so the user controls whether they need it or not. You also have the benefit that you can separate your own library code from the integration, so so the telemetry is kept separate from your logic, and also you can release, say, integrations for distributions that are released by someone else, etc. So again, an example, in this case, we're integrating with that spline reticulated from before. Some of this is just boilerplate. That dependency sub is there so that the system knows what modules need to be loaded for the integration to work. But the core logic is done in that install method or sub. The first thing that you would do is wrap around the method or the sub that you are interested in with, say, something like class method modifiers. And once you have access to the code that you're interested in, then you do the same thing that we did before. As if this was your own code, you just add the telemetry data there. So that's for libraries. But what about the application? All of that library is just using the API layer, which is doing very little work. What about the actual application? In the briefest sense, the only thing that you need to do is to connect the SDK. The SDK is highly configurable. The configuration so far, it's being done all through environment variables that define basically what format the data will have to when it's exported, what methods it uses for exporting, and where the exporting goes to. There is in the specification a newer section that defines ways to configure it using like a config file, for example, but that hasn't been supported yet. That hasn't been added. It's definitely in the roadmap, but it's only a limited amount of time. But before the SDK is going to do anything useful, then it needs these two components. It needs telemetry data that is generated either by you locally integrating or by loading an integration from somewhere else, and some means of exporting that data, which is provided by propagators that are configured when you load the SDK. So let's look at some examples. So let's say this is your application where you're doing some very important HTTP request. There's no telemetry data being generated here, so there's no work being done. You can load the SDK, which will internally read the configuration from the environment and configure any propagators that it needs to configure. But even at this point, there's no telemetry data there, so there's nothing to do. But if you load, for example, in this case, the OpenTelemetry integration for HTTP Tiny, that will hook into the HTTP Tiny library and generate telemetry data. And at this point, that data is going to start going wherever you told it to go to. And of course, you can do the same thing that we did before and just add telemetry data locally as well. So I think probably the easiest way of doing this is I have like a fake demo. So this is, let's say we run this command here, where I'm basically doing what I showed before. There's an HTTP Tiny request. And if I look at the headers that we would send, you'll see that there's no tracing data in there. But if I add the two libraries that I described before, the SDK and the integration, then you'll see that these new headers appear that basically define where they send information so that the span that is basically being generated, it says, well, if this belongs to this trace, and as this request progresses down the system, all the components can say like, oh, okay, so this is all part of the same trace. And if we modify that so that I don't look at the headers, but I look at the span that is being generated and exported, you'll see that there's all sorts of information that is being generated and captured. So there's stuff about the actual command that was run and the SDK versions and the sources of that. These are all attributes that are defined by OpenTelemetry. There's information about what generated the telemetry data. There's information that defines the span itself. And then there's information that locates the span in the broader context. So where do we go from here? What's the state of OpenTelemetry in Perl at the moment? It is currently working. I know that it's being used in production code. All of the core tracing functions are supported, and there's experimental support for logs, and currently no support for metrics. But metric support can be used, can be sort of provided using, say, like metrics any if you want to send it to Prometheus directly or something like that. Basically, you would be skipping the OpenTelemetry stage. You would just like be talking to the backend directly. But it has the benefit that it still provides the same modularity, and it's basically the same. This experimental logging support that I mentioned is basically doing something very similar. It uses an OpenTelemetry adapter for log any that you can then use to redirect log output into the OpenTelemetry sort of framework. Currently, all of this work has been done by me and a couple of contributors, but there's at the moment very little. The number of people that are involved in this is very little. So I'm here basically to advertise this project and to say we need more people, we need help. We need people to actually use it on production and to test it. I've been in contact with the OpenTelemetry folks who are very interested actually in having a Perl implementation. And in order to make this into like an official part of the project, there needs to be a special interest group created. And for that, there needs to be a buzz factor bigger than me, basically. So I need more help. And once we do that, then we can make this into like an officially supported part of OpenTelemetry and get all the goodies that we get from there. So if you're interested, please come talk to me. And I think there's a little bit of time for questions. If you need some suggestions, here are some suggestions. What is experimental about metrics? So in this case, that is a little misleading because there is nothing about metrics. The plan with metrics is basically to use the same one that we use for logs. So we want to have a metrics any OpenTelemetry adapter. So in the case of logs, we have an exporter, an adapter that connects log any into OpenTelemetry and takes care of like the encoding and everything. But basically, having log any there, it made very little sense to re-implement all this modular thing. We could just use that and also for free support OpenTelemetry in everyone who's using log any at the moment. So the same plan is there for metrics. And I think a lot of the work that I'm currently experimenting with logs, I can then basically use the same structure for metrics, but I need to get the log support out first. I could use your help. Yeah.
Two things, but the time inspiration that you mentioned earlier. It looks like it's only revenue recognized.
Yes.
So I want to do that on table
Right. Yes, you can. So there is a way to basically mark the context as untraced. So you say, whenever you get to a point where you say, well, I'm interested in all of these requests, but not these ones, you can say, well, at this point, I'm going to mark as the current context, a context that is marked as untraced. And then everything after that doesn't get traced. Yes. Yeah.
I guess the thing is, if you know, as a global, what happens if you're using
So I don't care. Like, like, so fundamentally, like, no, no, no. What I mean is that like the OpenTelemetry stuff, basically it doesn't care about, it makes no assumptions about whether the spans are sequential or not. The OpenTelemetry libraries that are on CPAN, they are built on top of IO async. So they integrate with Mojo. I am aware of that because I've been using it. And basically, the spans get exported after the fact, and they get exported in batches. So the exporter just sees spans that come in whatever order they finished, and then they get it sent to wherever you want. And then it's the task of whoever is processing the telemetry data to say like, oh, these ones fit together, and this one happened while this other one was happening. So it's their job to visualize that and organize that in whatever way it makes sense. Yeah. Yeah. Right. So, well, it's not global. It's, and I think Paul might be able to explain like the effect more better. But we are using the dynamically keyword here to set the context dynamic. So yeah, magic. Yeah, I mean, one of the cool things is that I'm using all of the new fancy things because this is a new library. So this is all using like ObjectPath and defer and the new try and all the goodies. Yeah.
I was triggered in a meeting years ago when someone introduced me to New Relic, and the guy was more like, no, elastic, yeah, the elastic version. He was bashing Perl there, and he was going on about that they don't want to have your code completely infiltrated with all these patches that I want to start spans here and spans there. So by the time I started working on open tracing,
Hi.
I had a very, very bright colleague that was having in mind that, oh my goodness, this guy is much brighter than many people that I know around me. He made it possible that you could actually wrap your code in spans in such a way that you don't have to touch your code anymore. He wrote a thing that's called grab scope and auto scope, these kind of things. And it comes with a tiny application that will analyze your code base, and it will help you to figure out which pieces of functionality, which subroutines are interesting enough to put actually inside your tracing stuff. Maybe that would be a very helpful feature for you, that you don't have to go patch your code everywhere. Don't flood it with all the telemetry stuff that has a config file outside of your application. Because people don't want to patch their applications to get telemetry.
Yeah. So the work that I did for Newfangled Agent, that was that does automatic instrumentation like the one that you're describing for New Relic. So you define like which packages and which subs you're interested in those packages and which ones you're not, and then will just go and like do some extremely awful things to the code and like basically just wrap everything, and it'll also hook into the require keyword so that any code that you load after also gets wrapped. I haven't gone that crazy with this yet. I know that we could do that, but I feel like it's probably a better idea to have the core system working first, and then we can think of like, well, how do we make it more convenient? So, for example, when Paul was talking about better attributes for subs, it would be nice to be able to say, for example, sub colon observed or tracked or telemetry or whatever it is. And then that will take care of wrapping the code without you having to touch it anymore. I'm very interested in looking for ways to make that a little more useful, but I kind of want to get it working first.
I've been there, you know.